Okay, so in this video I'm going to show you how to use the jar file to compute the pairwise modularity scores. So this is the adjacency list file for this graph. So again, make sure you just enter for every edge, the lower ID first followed by the higher ID. So that means one edge, sorry, 1, 2 is done like this, and you don't have to write 2, 1. So for every edge once is the lower ID and followed by the higher ID. So you have a total of 15 edges. So now make sure the cursor is in the last line and not a blank line. So now go to the pairwise modularity. So I've given you the zip file. So unzip it. You have this folder. So when you click on this folder, you see all these files. So you have to just double click on the executable jar file, pairwise modularity, and then load your adjacency list file. So this is saved under modularity score, modularity graph underscore 1.txt. Okay, so that will get you this output. So these are the pairwise modularity scores. You can save it to a file if you want to and later use in your calculations. Now let us just compare the numbers. So for exam purposes, all you have to do is, once you know the vertices that are part of a community, write down all possible combinations of node pairs. Say 1, 2, 3, 4 means it will be 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, and 3, 4. And for each pair, just write down from this output for pairwise modularity scores that you get the score. So you don't have to really write the formula 1 minus or 0 minus the product of the degrees divided by 2 times the number of edges. So this formula is actually incorporated in this code, and what you get is basically coming out from the formula. So as you see here, if the node pairs don't have an edge, it is 0 minus the product of the degrees divided by 2 times the number of edges. So the pairwise modularity score will be negative. If they have an edge, it will be 1 minus, so the score will be positive. Okay. Alright, so for one pair 1, 2 it is 0.7, for 1, 3 it is 0.6, 1, 4 it is 0.6, 2, 3 it is 0.6, 3, 4 it is 0.47. I'm rounding to 2 decimals here. For 2, 4 it is negative 0.4. So the sum is 2.57. Okay. Of course, you have to find out the sum. The output doesn't provide you the sum. So the output just provides you the pairwise modularity scores for all possible node pairs. So once you know your community, the vertices that are part of the community, you have to write down the different possible node pairs and pull out those scores for just those node pairs from this comprehensive output. Okay. So again, this code doesn't provide you the scores only for that community. It provides you the scores for all node pairs in the graph. So once you write down the node pairs, you have to pull out the scores for those node pairs from this output and just write down those node modularity scores and sum up their values. Okay. Right. So with that, we'll stop this video.